Hi everyone. In previous lesson, we will learn more about spreadness of data. Now we are going to know about the shape distribution of data sets. So we are going to talk about symmetric distributions and skewed distributions. Shape of distribution can be identified using two characteristics. One is skewness and another one is kurtosis. So what is skewness? It's nothing, just a measure of asymmetric, or you can say lack of symmetry. If we have a symmetric situation here, so what's the lack of symmetrical gives us these two situations, the negatively skewed and the positively skewed. Let's find out in more details. Suppose we have a data set and we plot it in a histogram plot, and it looks like this one. Now let's try a curve on it, and it shows a more or less approximately a symmetric distribution. And if we take a center point, so this is called a symmetric distribution because it is symmetric, or you can say it's symmetric about some center line. So if I look here at the center line, the distribution is a mirror image of itself on both sides of the center line. So this left half of the distribution is a mirror image of the right half and vice versa. This curve is particularly called a normal distribution. It's really a special kind of distribution which is a bell-shaped curve. This is called a bell-shaped curve. But a symmetric distribution doesn't always have to be normal bell-shaped curve. In fact, it can take on any shape as long as it's symmetric about the central line. So no matter what it looks like, if the left hand side is a mirror image of the right hand side, you can call it a symmetric distribution. The line right down the center line will always be where the mean occurs, and the median is right along the center line as well. So for symmetric distribution, we have actually same mean, median and mode value belongs to this central line. All three, mean, median and mode, have this value on the center line, the line that makes the distribution into two equal parts. In contrast, we can also look at a skewed distribution. So again, we will have the same type of plot using a different data set, but our distribution might look something this, which is a little different from symmetric. So instead of the area under the curve being equally distributed on either side of some center line, in a skewed distribution, the area under the curve is either shifted to the right side or shifted to the left side. When we look at a skewed distribution, like this smaller area over here, on the left is low area right here. We call the tail of the distribution. Therefore, because this tail of this distribution is on the left hand side, we could call this distribution as a left skewed or left tailed distribution. As you can see, there is a long tail. It's also known as a negatively skewed distribution. When you are trying to remember what to call the distribution, just think about where the tail is. As it is in a left tail, you can say it's a leftly skewed or left-tailed distribution. Now I have sketched it very roughly to be representative. So what's the matter? Where is the order? So like symmetric distribution, where is the mean, median and mode in this skewed distribution? Now let's find out where the mean, median, mode belongs to this skewed distribution. As we know, symmetric has all in a same center point, but for this kind of skewed distribution, the mean, median, mode has different center points. as you know, the mode will occur at the peak of the distribution. So wherever the distribution is the highest, that's where the mode will be. So that's why the mode is here, and the median is always between the mean and mode value, and the mean is on the left side in this left skewed or negatively skewed distribution. So which value is larger here? Think carefully. You can see these are the classes, or you can say in x-axis these are the values. So if you observe closely, the value is increasing here. So we can say mode has the maximum value, then median, then mean. That means mean has the smallest value in this type of skewness. So you can say for negatively skewed data set, mode has the largest value, then median, then mean. Now let's take the another graph which gives us this kind of situation, which is exactly the mirror image of left skewed or left tail, or you can say negatively skewed distribution. So this is known as right skewed or right tailed or positively skewed distribution. As we said, if you can't remember the name, just see the where the tail belongs to. So there is a long tail in the right side of a graph. So that's why you can say this is a right skewed or right tailed or positively skewed distribution. In this distribution, let's find out where our measure of central tendency belongs. As we told before, the mode will be in the peak of any graph. So here is our modal value, and after that our median value between these two, mode and mean, and the mean is on the right side. Now in symmetric we see all are equal, but in left or negatively skewed we see the mode is larger and the mean is smaller. In right skewed you can find out that mean has larger value compared to the median and mode has the lowest value as it started high in the starting point. So that's the ideal situation for rightly skewed data set, where the mean value is larger than median than the mode. So if we take the summary here, the normal distribution, which is the symmetric or the bell-shaped curve, has the skewness 0. That means there is no skewness at all, and here mean equal median are equal to mode. A distribution with a significant positive skewness has a long right tail, has a skewness greater than 0. That's why it's called positively skewed or right-tailed or right skewed shape distribution, where mean has larger value compared to median and mode. And a distribution with a significant negative skewness which has a long left tail, and this is the opposite of the right tail or positively skewed, is known as a negatively skewed distribution, where this skewness gives us the value less than 0. That means it gives us a negative value. Here the mean value is the lowest one and the highest one has the modal value. Now remember, most of the time we can show this distribution or the shape using the graph, but sometimes you have to calculate the skewness or the symmetric value. So after applying the formula, if you get the value of skewness equal to 0, you can say the data set is a symmetrical distribution. And except of this situation, if you have a greater than 0 value or a negative 0 value, and except this situation, if you have a positive value, then you can say it's a positive skewness, and if you have a negative value, then you can say the data set is a negatively distributed data. Let's find out the formula how to calculate skewness. So the first one is Pearson coefficient skewness, where we need mean, median and standard deviation. The formula is 3 into mean minus median divided by standard deviation, and another one is mean minus mode divided by standard deviation. So to calculate this skewness you need these three measures. These are two the central tendency measures, and the standard deviation is the measure of dispersion. There is another formula, Bowley's coefficient of skewness. These are the quartiles value. You can use this one also to find out the skewness. You will learn more about quartiles in the next week lessons. So if we have a distribution like mean, median and standard deviation value, can we find out is the distribution is positively skewed? How, and what is the value of coefficient of skewness? Yes, we can. If we use the Pearson's coefficient of skewness and using this value, we will get a skewness value which is greater than 0. So according to the skewness law, we can say that the distribution is positively skewed because the coefficient of skewness is greater than 0. So any positive value actually tends to the distribution into positively skewed distribution, and the value of skewness is 0.42. Now let's take another example. A random sample of 20 people was taken to know the time past Facebooking during last 2 weeks. The recorded data was given below. Let's calculate the measure of coefficient of skewness. So using the Pearson coefficient, you can have this formula 3 into mean minus median divided by standard deviation. And after calculating these three measures, mean, median and standard deviation, we have finally found this value, which is a negative value, that means less than 0. And we can say the distribution is negatively skewed because the coefficient of skewness is less than 0. And the value of skewness is minus 0.36. That means we can say this is a left-tailed or leftly skewed data set or negatively skewed data set. Now let's try the different version of the formula, which is mean minus mode divided by standard deviation. Now we have the mode value, which is 93 here for the data set we are using here, and it gives us a negative value. But look at here, this value is a little different from the others one, but the sign is similar. So we can also say here that the distribution is a negatively skewed or left skewed as we have a value which is less than 0. So remember one thing, which skewness formula you are going to use or whatever the value is, that doesn't matter. All matters is it greater than 0 or less than 0. If it gives us a greater than 0 for both of the or all of the skewness formula, then you can say yes, this is a positively skewed distribution. But if this gives us a negative value for all of the skewness formula, then you can say it's a negatively skewed distribution. Remember, the formula can vary, so you don't need to worry about these values, but you have to worry about this sign, or you can say the direction. Is it 0, is it positive, or is it negative? Kurtosis is another shape distribution. This is kind of measure of the extent to which observations cluster around a center point. It mainly provides the peakness, which distribution has how much peak. Like the data set which has this kind of high peak is known as a leptokurtic, and which data set has a more or severe type of peak is known as a mesokurtic, and which data set a very less peak, you can say very flat also, is known as a platykurtic. So if we put the central value type of situation here, like if this is the central value for the leptokurtic situation, which is the high peak distribution, most of the data is around this center point. That's the peakness. And in mesokurtic, we have seen the data set is more or less a little spread compared to the leptokurtic, and this is known as a mesokurtic. And a data set which is very much in a scattered way is known as platykurtic. So that's how actually kurtosis works, by measuring the peakness of the distribution. So that's all for this shape of distribution. Mainly we are using skewness to most of the cases shape of the distribution. Now try to answer the quiz.